Hello friends, we are on quadratic equations. We have seen how to solve quadratic equations. We have seen three methods. Now first method was factorizing, second method was completing squares, and then the third method was using quadratic formula. Okay, now today we are going to solve simultaneous equations. Now out of these two equations, one is a quadratic equation and other is a linear equation. Now linear equation is just one type that we can have, but then you can have equation of a curve, equations of two different curves, right? And you can find out the points of intersection of the two curves, right? Over here we are going to take only lines and quadratic curves, right? So now when we have one quadratic curve, maybe like this, okay, and there can be a straight line. Okay, now we want to solve simultaneously. That means I want to find points of intersection of line and this curve. Now in how many ways can you have this scenario? Okay, what you can have is, the line cuts the curve in 2 points. Let us say point A and point B here. The line may cut this curve only at one point, so maybe this point C here. So we can say my line L1 is cutting this curve y is equal to ax square plus bx plus c. Okay, and here my the second line L2, it is intersecting the curve at only one point. That means this line is tangent, correct? So we need to understand that. Or then my third line can be something like this, L3. Now is it cutting this curve? Is it cutting this quadratic curve? No. So that means if I have to find the solution here, okay, we are not getting any points of intersection, correct? So then there may be some something over here which we would like to definitely see, right? So let us take some examples. Now let us have this curve, this quadratic y is equal to x square minus 2x plus 8. Okay, and my straight line, okay, it will be x minus y plus 6 equal to 0, correct? So now we want to solve this. Now how do we do this? Y is equal to x square minus 2x plus 8 and x minus y plus 6 equal to 0. So now what we will do is we will express y in terms of x. So I'll take this y on the other side. So I have x plus 6 is equal to y. So this is number 1 and this is number 2, right? Now what do we do? Now I substitute y is equal to x plus 6 in this equation. So I can say y is equal to this and y is equal to this. So I would say x square minus 2x plus 8 is equal to x plus 6. Now what do? I take everything on my right hand side to left hand side. So it would be x square minus 3x plus 2 is equal to 0. Now what? Now you have a quadratic equation here, correct? And if you solve this and get the values of x, correct, then you get you may get two values of x. Let us say how many we get, and with each value of x you will get your y, correct? And then you get 2 points of intersection. Let us see whether we get it. Now here I am going to solve by factorization. So plus 2. So plus 2 is equal to minus 2 into minus 1, correct? And minus 2 minus 1, that is equal to minus 3. So I am getting the middle term also here. So I will write x square minus 2x minus x plus 2 equal to 0. That makes it x minus 2 minus x minus 2 equal to 0. So then that makes it x minus 2 into x minus 1 equal to 0. And then what does it mean? It means that either my x minus 2 is equal to 0 or x minus 1 is equal to 0. That gives me x is equal to 2 and x is equal to 1. Correct. So now what do we do? From these values of x, I'll get my values for y. So my y is equal to x plus 6. So y would be, now when I'm taking x equal to 2, so 2 plus 6, that is 8, or y is equal to x plus 6 again. So I'm putting x is equal to 1 there, 1 plus 6, that is equal to 7. So my points of intersection of this quadratic curve and this straight line, okay, that would be, let's call those points A and B. So my A is equal to 2, 8 and B is equal to 1, 7. Now here you are getting two distinct points. Okay, this the line and the curve, they are intersecting at two distinct points. Okay, so what can you say about the discriminant over there? So discriminant must have been greater than 0, correct? Discriminant, my delta, which is b square minus 4ac. You must remember that solutions of this quadratic equation, so minus b plus or minus root over b square minus 4ac divided by 2a, correct? These are the roots of quadratic equation, and when you have discriminant greater than 0, you get two distinct roots of the quadratic equation, correct? Now since I am getting two distinct roots, that means my discriminant must be greater than 0. Now what if discriminant is equal to 0? If it is equal to 0, then you should get both the roots, you should get real and equal roots, correct? And what happens if we get imaginary roots, or then the roots are imaginary, or then you can say no real roots possible, isn't it? I think we must take an example for that as well. So let us take this example. Okay, now here I have written fx is equal to minus x square plus 4x minus 7, and the second one is gx is 5x minus 4. Now obviously this equation can be written as y is equal to and y is equal to. Okay, now what do we do? This is my straight line and this is the quadratic curve. So we are going to follow the same procedure. Okay, I'll substitute for y in one of the equations. So what I do is minus x square plus 4x minus 7 is equal to 5x minus 4. So next step is take everything on the right hand side to the left hand side. So I'll write here minus x square plus 4x minus 5x minus 7 plus 4 is equal to 0, correct? So minus x square minus x minus 3 is equal to 0. Now I multiply both the sides by minus 1. So I get x square plus x plus 3 is equal to 0. Okay, now I don't think there is any possibility of factorizing 3 such that the sum is equal to 2. So I won't be able to find the any integer like that. Okay, so what I'm going to do is I'm going to directly use quadratic formula, and here first of all I'll evaluate what is my discriminant. So that is b square minus 4ac, right? Now in this case A is equal to 1, B is equal to 1 and C is equal to 3, all positive. So my B square would be equal to 1 square minus 4 multiplied by 1 multiplied by 3. So that is equal to 1 minus 12, which is minus 11. So obviously roots are x is equal to minus b plus or minus root over delta, that is discriminant divided by 2a. Now since my discriminant is equal to minus 11, right, the roots will not be real. So there are no real roots available for this quadratic equation. So what does it mean? It simply means that this line and this curve, they intersect at no point. That means it would be something like this. Maybe, you know, it's like this, and that line may be like this. Okay, at no point does the line and the curve intersect. So that is how we solve two equations simultaneously. One of them is a quadratic and the other one is a linear equation. Now here, you know, as we said before, the line can intersect the curve at two distinct points. Number two, the line will intersect the curve at only one point. That means the line will be touching the curve, or that means the line will be a tangent to the curve. And third possibility is line and curve will never intersect, and so that means the roots of quadratic equation that you are going to get, the roots are going to be imaginary, okay, not real. These are the three possibilities. Now there are different ways in which questions could be asked. Okay, now, you know, maybe I have a curve like this and a line intersecting the curve. Okay, I get these 2 points, point A and point B. Someone may ask me, find the coordinates of the midpoint of this chord, okay, midpoint of this secant. Or then maybe you would be required to find the equation of perpendicular bisector, correct. Now with these 2 points, you know the gradient of AB, correct. Now gradient of AB and the gradient of perpendicular to AB, okay, their product is going to be equal to 1. So you can figure out what would be the gradient of perpendicular, okay. And if they say perpendicular bisector, you also know the midpoint, right, and then perpendicular bisector. So you by using the simple forms of equation of a straight line, like you can have slope point form, or you can have you know, double intercept form, or any form, maybe y is equal to mx plus c and so on, and you can get any equation from that, correct. So that is how, you know, we solve simultaneous equations, you know, one curve being a quadratic and other one a straight line, right. Thank you so much.